Today we will discuss how the signal is amplified by the transistor. Transistor amplifier. This is like the weak signal which is given to amplifier, and it gives us a strengthened signal, maybe in phase or maybe out of phase. This is out of phase signal, but it is amplified. So how the transistor amplifies? So basically we have to understand the transistor first of all. So this is an NPN transistor. NPN. This is emitter terminal, base terminal, collector terminal. Emitter, base, collector. Okay. There are two junctions, emitter base junction. First of all, this one. This is a forward. This junction to become forward bias. This is emitter base junction, and there is second junction. There is the collector base junction. This is collector base junction. So there is an emitter base collector. The emitter is heavily topped. Base is very lightly topped. They very lightly topped the base. And collector is the moderate. So there is NPN, but you cannot change emitter to collector or collector to emitter, because emitter is heavily topped and collector is moderate. Of course, both are N. Emitter is wider, base is very thin, and collector is still more wider than emitter. This is a physical, concept. Physically, collector is more wider than emitter, and collector is less topped as compared to emitter. If the emitter junction is made forward biased, emitter base junction is forward biased, collector base reverse biased, then this is normally this is the working of the transistor. Transistor works like this, and it is in an active region. Transistor, it is in active region, and it acts as a linear amplifier. So emitter base junction should be forward biased, and collector base junction should be the reverse biased. Now if emitter base junction is reverse biased, collector base junction is reverse biased, then what will happen? Oh, the transistor will be in cutoff region. It will not work, because both junctions are at reverse biased. If emitter base junction is forward biased, as well as collector base junction is forward biased, again this is not a good situation. This is called saturation region, because the collector current will be saturated. The collector current will be constant. It will not change with the base current. So this is not the working region of a transistor. So there is no effect of collector current on the emitter, base current, if it is a common emitter. So mostly their configuration of the transistor: common base, common emitter, and common collector. Basically, two are mostly used: common emitter as well as common base. Common collector is very rarely used. And there are two types of transistor, NPN and PNP. Mostly transistors are NPN. You think why? This is a question for you. Okay, why the NPN is mostly used? This is just a homework for you. So if we make the emitter grounded, then it is common emitter configuration. If the base is grounded, then it is called common base configuration. So there are three currents: base current, emitter current, collector current. And emitter current is always the sum of base current plus collector current. This is the basic equation of the transistor. Now, what is the principle of amplifier? Any small change in the base will produce a very large change in the collector side. Any small change in base produces a very large change in the collector side. So what is the transistor current equation? Very simple. Emitter current is the sum of base and collector. Base current always in a very small microampere, emitter in milli, and collector in milli. IB is very, very small base current because it is a microampere. Now, what is current gain in case of common emitter and common base? In common base, it is abbreviated as alpha. In common emitter, it is abbreviated as, it is written as, it is specified as, it is defined by beta. So, what is alpha? Alpha is current gain in common base, output current over input current, that is IC over IE. And if we think, this is just a let, if it is 100 unit emitter current, base current is 2 units suppose, and collector current 98 units. Then what will be the gain of common base? Collector current is 98 divided by emitter current, which is 100, that is 0.98. It is less than 1. So if it is less than 1, it is not actually a gain, but it is a loss. This is again a question for you. Why the alpha is called a gain? As it is coming less than 1 here. Now we are coming to beta. These are all the DC conditions, remember. We are not applying the signals then. Now here we are discussing without the input signal under DC conditions. So what is beta? Beta is current gain in common emitter, IC or IB. What is IC? 98. What is IB? 2 units. 98 over 2, it is 49 units. So this is good, very good current gain in common emitter. This is, answer why common emitter is mostly used. Now we will see how the transistor amplifies the signal. We will consider two resistors, R1 and R2, one fixed and one variable, and we give voltage at one point and other will be grounded. Like this is voltage 100 volt given at one point, R1 and R2. R1 is red, which is fixed, R2 variable. Now it is here 40 ohm, no problem. Current, what is will be the current? 100 over 100, 1 ampere. What will be the voltage across 40 ohm? that is resistance into current, 40 into 1 ampere, that is 40 volt. Okay, 40 volt will develop across the 40 ohm resistor. If we make the 40 ohm variable, then any voltage can be set across the second resistor variable. Let it is, if it is 140 ohm we change, then the current will be 100 over 200.5 ampere. Voltage across 140 is 70 volt and 30 volt will be across the 60 ohm. So changing R2, the change the voltage. If R2 is variable, then any voltage can be set across R2. Now we are thinking by some voltage we change the second resistor R2. Okay, if we set some voltage V in which will change R2, then voltage gain will be V0 over V in. Now we are thinking, if we consider a transistor as a variable resistor whose resistance will change by the base current or the base voltage, then because transistor are also variable resistor whose resistance depend upon the base voltage or base current. Now the circuit will be like this. So V in, V out, transistor. This is the resistor between collector and ammeter, and this resistance depends upon the input voltage, the function of the base voltage of the base current with respect to ammeter. So any type of change in V in will give a change in V out in volts. If V in is in millivolt, V out will be in volt. The same change appears at V out. So this is how the signal amplifies. Okay, thank you. Now